So now we have seen plenty of examples of using your slope formula to calculate the slope. But why do we use the slope formula if we can graph it? Like in the previous example, we were given points and we were able to plot those points on the graph so that we can count the number of boxes and find the rise and the run. Now it turns out there are times when you can't draw those points on the graph, especially when it comes to decimal coordinates or coordinates that involve fraction, square root number, or something else, other numbers that we are not familiar with. If we can set up an equation using the slope formula, we will be able to solve a lot more problems. Like the one in example number 4. They give us 2 points, but something is missing. Luckily, we have the slope given to us, and we are going to set up an equation using the slope formula to find the unknown. In this example here, we have 2 points, x1, y1, x2, and y2. They are the xy coordinate of point number 1 and the xy coordinates for point number 2. We also have the slope given. If we can substitute all of them into the equation, we will be able to solve for the unknown. So starting with the slope, m equals 3. We have y1 minus y2. And we have x1 minus x2. We want to solve for this. If you are not quite sure what to do for now, do the ones that you know that can be done right away, such as the denominator. 2.9 minus 4.1. What would that be? Negative 2.8? No? What else? What could it be? Negative 1.2? A positive number minus something bigger than that will give us a negative value. So you will end up with negative 1.2. What's next? We are still trying to solve for this, but what else can you do? Times negative 1.2 to the other side. That's how we can get rid of the denominator. We are still trying to solve for this. What do you do to get rid of this part? How do you bring it to the other side? How? Yep. The minus 3.7 will now turn into positive 3.7. Minus 3.6, we will end up with 0.1. So that will be the y coordinate for point number 1.